Okay. Well, good morning, everybody. I'm glad to see such a big show up. This is a talk that I usually do in 60 minutes, but because of the fact that the title is faster, shorter, smaller, and again faster, I mean flatter actually, but I'm going to do it a lot faster because I only have like 37 minutes. So I'm going to talk really fast. So I'm apologizing beforehand just for you. If it goes too fast for you, I'll be here the whole day to answer questions and talks and drink beer, I hope. What time is it? Is it time for beer yet? No, not yet. Anyway, so let's get the show on the road. So this is me. My name is Sander, and it's probably too difficult to pronounce my last name. It's in Dutch, so I'm from the Netherlands. In Dutch, it is Hoogendoorn. Doesn't help, right? In my daytime job, I'm a programmer actually, with a big mouth. So I'm a dad, an independent dad. This is my son. I brought him with me. I have more, by the way, but I couldn't bring them all. And so I'm basically a programmer. I write, I speak at conferences, and I'm currently, as an independent consultant, the CTO of a company that builds software for the insurance market. I'm going to do this really fast. So my Twitter tag is on there if you feel the need to tweet. If you feel the need to email me, my email is on there too. And yes, I've written a couple of books. They're not really helpful here because they're in Dutch. Unless you understand Dutch, but there's only 2 people here outside of me who do. And so they're about UML, about modeling, a couple about agile. Oh, that one's been translated to English. And it has 2 additional chapters, one on enterprise agile, which is really thin. It just says don't do this. And it's also there in German, which is basically twice as thick because they have much longer words. So, and I'm writing some new ones, one on microservices and one on the continuous culture, together with Kim, and that's basically the topic of today. So that's why we're here. Now, first of all, let me try to explain to you that the world we're living in, and you've probably all seen this before, is that it is changing. And it isn't changing slowly, it is changing big time, right? Technology is helping us change the world. So we, as developers, are really powerful because it's us that change the world, right? You have to understand that. It's a big responsibility for us, basically. So what is happening? Now, if you look at this particular graph, and you've probably all seen this is called Moore's Law. And Moore's Law basically says that the number of transistors on a dense integrated circuit increases it doubles approximately every 2 years. Now, if you look at the line on the graph, it looks linear. It isn't, right? It's logarithmic. It goes up like this. It changes faster and faster and faster. And the change is going faster and faster too. Which basically means that the power we have is doubling every 2 years. The power we as developers have, right? We all do all the change. Let's look back into history really, really briefly. This is basically if you ordered a computer in 1954. Remember, there was no internet back then, so you couldn't order it online or whatever. If you order it, it was brought to your house like this. This is basically a home computer, right? 1954. Of course, nobody of us was there yet. And if I look around the audience, I'm probably one of the oldest guys in the room. So is anybody of you born before 1970? I was in Poland 2 weeks ago, and there was nobody there who was born before 1970. Here, there's like 4 people, and I'm one of them. I'm from 67, right? It's a summer of love. So back in the 80s, so things changed. Things got smaller, right? This is IBM's personal computer, the 5150. You could buy this in 1980 for $3,000, right? For what it's worth. And you had a system that had 64K bytes, right? You're too young. You don't really appreciate 64K, right? We could write code back then, having only 16.4K of RAM. Isn't that incredible? Try to do that. If you do NPM, it's just, there's things that are heavy, like the Earth is heavy, the sun is heavy, and then there's a black hole, and then there's NPM modules, right? So I'm not joking about JavaScript today. Anyway, so this was state of the art. I had one, right? And it had a floppy disk. You don't know what a floppy disk is, right? It's the save icon that you use, right? That's coming from a floppy disk. Right? You know? Okay, cool. Yeah? Pretty cool. I did a guest lecture at a university a couple of months ago, and they've never seen one, actually. They don't know what it is. Times are changing. And then in 2006, Amazon had a great idea. They said, you know what we'll do is we'll create hardware somewhere in the world and allow you to use that. Of course, you have to pay us for it, but that's how it works. So they created EC2. And that means that instead of using your own machines and your own memory and your own hard disks and your own whatever, you could use somebody else's. Just you have to pay for it. But that gave us way new opportunities, right? The cloud opened up opportunities that we never could realize before. I used to be the CTO of an insurance company in the Netherlands, and they renew insurance policies every month, a couple of million, right? And on the software they had, which was written in COBOL, that ran the whole weekend. Now, if something went wrong during the weekend, they had to redo the whole thing on Monday, every month, right? And being that the single system that they had, nobody could work anymore because they had to shut down the whole system to be able to renew the policies. And then we came in, we moved it to continuous delivery, moved it to microservices, we moved it into the cloud, so it was scalable. The same process ran in 28 seconds, right? That is the change that the cloud is bringing. And it gets worse because now there's AI. I used to study AI when I was in university, but that was way before the stuff that we're doing with it now, right? That is totally different. Like Microsoft, for instance, is now trying to help health companies trying to cure cancer because there's lots of DNA crunching that you need to do this. And they have the computing power to help other people to do that, right? So that is changing the world again and again and again. Just to give you an idea about how fast things change. If you look at technologies, the acceptance rate of technologies, before they reached 15 million users. Now 50 million users for airplanes took 68 years, right? And if you look at the different technologies, like electricity took 46 years before 50 million people had electricity. Can you imagine that? 46 years. Like an ATM to get money out of a bank took 18 years because before 50 million people used it. And if you look at modern technologies, it's going much and much and much faster, right? Like the adoption rate for Facebook, although it's probably lowering right now, it took 3 years to get 50 million users. Twitter took 2 years. Pokemon Go took 19 days to get 50 million users. Now that is the rate of change that we have, right? I'll tell you a little story additionally to it about finance, right? In the Netherlands, there's a whole lot of startups in the finance market, like a couple of thousand actually. What do you figure? What if you are a big bank? Like we have big banks in the Netherlands, big international banks. They have loads of software and loads of hardware, tons of it. They have like thousands of people working in infrastructure at a bank, right? That's what banks do, basically traditional banks. What if one of these startups actually figures out how to build a banking system with 10 developers, probably from here, and then put it into the cloud, having no machinery in their offices. Like they have these really small offices somewhere, some hipster office, and they'll be able to build that, right? With 10 people? Do you think they can compete with big banks? Oh, yes, they can, right? And the thing is, those are not the only companies coming into the finance market. Just as an example, right? This is the CEO of the ING Bank in the Netherlands. He just got a salary raise, and then there was a political uprising, and then they canceled his salary raise. I don't know, but this is a company. And he says, basically, it's not the startups that are our biggest competitors. It's the companies such as Amazon. Amazon, Apple Pay, Google Pay, those will be the companies that will compete in the finance market. And then other companies join in too. I read this a couple of weeks ago, saying that, well, it's actually, well, it's from 2017, so it must be some months ago, that a low-cost airline from Asia is actually going to come into the payments market because, it's still on, right? Because they're just able to, because they want to be able to get people to pay for their drinks in airplanes. That means that they're going to move into finance as well. So everybody's going to do finance. Yeah. Is the microphone still? Can you still hear me in the back?
Yep.
Oh, good, because it sounds different from here, right? So basically, markets are going to change big time, and we, again, as developers. What? It's gone.
Дайте замену микрофона.
Maybe the battery's gone. I can speak really loud though, but I'm not really sure what you hear. And again, in the other rooms, you won't be able to. Ah, new microphone. Change is coming. Yeah. See, change is really, really fast. And even me as an old guy, right? I'm already, oh crap. My mother used to say, what his eye see, his hand can break. So I'll try to repair it. So basically, we're the ones changing this stuff, right? We are the ones changing the world. And if you look at it, this is basically my assumption, that this is what we're going to do. Software development is going to change basically because of our own work. Basically because we developed the technology to allow our field to change as fast as we can. And I think this is going to happen. Basically because we need to be faster. We need to be faster all the time, because if we're not, one of our competitors will be, right? This is a tough market. And if you've seen the finance market, what will happen to that? Banks, traditional banks, will have big problems keeping up with new companies coming into the field. That will happen in every field. Again, in software development, I think what we'll start to do is that the metaphors for doing software development will change, right? The metaphors of doing projects, traditional projects, will disappear, I hope. I hate projects, so I'll explain that a bit. I think what we'll start doing is more and more is just build products, because building products feature by feature is basically a much better metaphor for what we're doing in this field. To do that, we need to have shorter cycles. Are you doing agile projects? Who of you is? A bit, right? So agile's been here for almost 20 years, right? And again, agile will also evolve. And it will evolve into something that is even more continuous, with much shorter cycles than traditional agile approaches have, into something that allows us to deliver software much faster and much more frequent. To do that, we need self-organizing teams, almost autonomous teams, small autonomous teams, basically. And last but not least, but I'm not going to talk about that today, we will need software components that we actually can deliver at very short notice, that we actually can deliver in like a day, or maybe in 2 days, and then add the next feature to it in maybe another day, right? So that's how the world is going to change. So let's look into that. I tend to refer to this as the continuous culture, because we are slowly moving into a continuous fashion of delivering software every day. If you look at the applications on my mobile phone, I usually say apps, but I don't know why I say applications. If I look at my mobile phone, these apps update themselves almost every day, right? Even Facebook. Not too long, I think, but anyway. So, and we will do that in the rest of the industry too. Our industry is actually leading towards doing things more continuous. Other industries are actually following suit. It used to be the other way around, right? We used metaphors from building houses, from factories. We work in a software factory. Oh, I hate that, by the way. And it's not that way anymore. We have our own metaphors. And our metaphors of delivering continuously in small teams are actually changing the world. And that's a good thing. So let's go. Basically, we will start with this. I think the whole idea of doing projects with a deadline and delivering some functionality at the end of the project, which is usually 2 years down the road, given a bunch of resources. Do you like the term resources? I don't, by the way. I always correct my project manager. No, we're not resources, we're people. It's even on my laptop, I guess. So we are, right? And the whole thing about this project, I think, is actually wrong. It doesn't fit our industry. And I'll explain to you why, using this particular model. It's called the Cynefin model. It's written by a guy who is a professor in a university in Wales. That's why it has such a difficult name. Maybe it's less difficult for you guys, but for me, as being Dutch, I don't know how to speak Welsh. And this is an interesting model. Now, in this model, he says, there's the simple zone. The simple zone has problems in it that you can easily solve, right? Building a list of the phone numbers of your friends, we can all do that, right? We can do that in any language, even in Java, although it needs lots more code than in other languages. So that's easy, right? We start doing these things in the 80s. We could do that, build some simple spreadsheet or some small program, etc., etc. And then there is the complicated zone. Now, in the complicated zone, that is where most project managers think that their projects actually are in software development. They think that if you think about a problem long enough, if you put in enough analysis to do that, and you think about it hard and thoroughly, you can actually solve it by doing that. So you create a big design, and once it's done, after half a year or so, you'll have it built by some resources, right? And in the end, you will have a decent project. The problem with this model is that we have never been in this particular zone, because everything in our world, in the world of software development, changes so fast, including demands and wishes by clients, including laws, including regulations, including technology, of course, including the people in projects. It changes so fast that the whole idea of saying we're able to write down all of the requirements, structured, for half a year, and then build this whole thing for another 2 years is actually not working. And it has never worked in this field, because this is such a volatile field, right? We need to be more agile, basically. Because we have basically always been in the complex zone. Now, the complex zone, the problems that are in that particular space, you cannot do enough analysis and then solve it, because it will change under your hands, right? The only thing you can do is you can say, I want to be somewhere up there in 3 years' time, and we'll try to move in that direction, solving a small part of the puzzle. See if the technology we use works, if the frameworks we use work, if the architecture works, if the people can actually build it, etc., etc. Take a small step. If it works, continue in the same direction. If something goes wrong, and it usually does, I've been in software development long enough to know that everything will fail, actually. And then you try something differently, or maybe use a different framework. Get some more modules into your NPM installment, and then move that direction and that direction. In the end, you will end up somewhere there, not exactly at the point that you hope to get, but that is the most realistic path you can get. And it goes a bit like this. That is the complex zone, and you all recognize that probably, because that is where we are. So the whole metaphor of doing projects, that whole traditional iron triangle of project management, like you have some time, some limited amount of time, a limited scope, and this is the money you can put into it, meaning you can hire resources. That whole model did not work in this industry. We've tried it for a couple of years, 40, 50, didn't work, right? Most of these traditional projects have basically failed. There was a parliamentary inquiry in the Netherlands 4 years ago, and they investigated the 37 biggest IT projects done by government. They all failed, all of them, right? That is terrible, right? This whole metaphor we should have never used in this industry. It's just that wrong. So also, all these detailed plannings that you might have, they'll never come true. They never have in this field. So stop doing that. In one line, you should stop doing projects, basically. Thank you. The thing we should do is realize that all the time that we're working on this stuff, we should be building products. We are building products. Everything we do is a product. From the first small thing that you build, show it to the customer, and the customer says, oh, looks good, but can it also do this? And you say, wait, we'll come back tomorrow. We'll also have it do this. And then the next feature comes along, and then the next feature, and the next feature, and the next feature. You should build your software feature by feature, basically. Just follow the roadmap. Stop doing all this planning stuff, because it doesn't work. Take a roadmap. Make a list of the things that you need in your product, and start building with the most important one. And then the Cynefin model, this model comes in really handily, because what you can say, with every one of these particular features. You can talk to the client and say, you know, dear client, if this is the most important feature, what version do you want of it? Do you want a simple version that we can deliver tomorrow? Or do you want to have more additional features to it that we can actually deliver in 2 days or in 4 days? Or do you want the whole shebang and we'll build a whole car just from this feature, but it will take us 3 months? Usually the customer will say, you know what, give me the simple version, like the skateboard version or like the bicycle version, and not the car version of this feature. That saves a whole lot of time, right? And then you pick the next feature from your roadmap and you say, okay, what's the next feature? Dear client, how do you want your next feature? Do you want it to be a skateboard again? And then maybe the client says, oh, I know, you will add this stuff in here at this time, right? So you take the client along the roadmap that you pick up. Adding new items to the roadmap, you can do that all the time, right? Because that's how your roadmap works. It's not a fixed list. Now that is going to change the things, the way we work. Also, this is something I taught my teams, by the way. Do you know how this is, by the way, in this picture? I always put her up here. This is one of the most important women in IT industry. This is Grace Hopper. She invented COBOL. She was also the first one to find an actual bug in the system. She's an amazing woman, actually. So I have a bunch of my heroes hanging on pictures in my toilet. So it's basically heavy metal dudes, and she's in there too. No, true, this is the same picture I have in my toilet. So basically, the thing I always teach my teams to do is to ask continuously this particular question. For anything anybody comes up with, whether that's the client or the architect or yourself, always ask the question, do we need this now? If that isn't the case, then there's probably something else that is more important and needs to be done first. If you do this all the time, your work will become easy. Also, argumenting with your colleagues is also easy. If they come up with a brand new idea, like, okay, we should build this particular feature and use whatever framework we're using, do it in React and Redux and whatever, sometimes. And then you say, okay, do we need these now, or can we just do Angular, right? Okay, let's do that. And discussion done, right? It's easy, makes our work easy. So always ask yourself that question. And by the way, you should stop doing projects, really. Just go back to your managers on whatever, Monday, and tell them, we're going to stop doing projects, right? This stupid dude from the Netherlands says we're not going to do projects anymore, so we're stopping doing it. So, really true. Even shorter cycles. We have to talk about that too. But, because you've seen Scrum before, right? Do you like Scrum? Somebody does in the back, right? Okay. There's always one of them. And so Scrum is okay. It's a fairly simple framework to do agile projects with. And what we see a lot in the Netherlands is that people who are starting to do Scrum, they now go to bigger companies, and bigger companies say, we need enterprise agile. I haven't got a clue to what it is, but people need that, right? And you can earn lots of money by saying you're an enterprise agile coach. Ooh, you can get really rich from that. So the question is, what do you do if you do enterprise agile, right? Is it just multiple scrums and then you have the scrum of scrums to structure it all together? Not really, actually. Doesn't work. Or should you do SAFe? Have you seen this? If you see this as in a company, go away. This has nothing to do with agile. This is just consultants making more money, wearing ties, making more money, going into companies and sell companies enterprise agile. You can sell this at board level, right, at a company, not at developer level. What is a release train? What does it do, right? A train is actually not really agile. It's just running on rails. There's no deviation from the path, right? So it's not really agile. Or So what about Spotify? Do you like the Spotify model? Is anybody of you using it? Also a few, right? What, sorry? There's no Spotify in Russia? Oh, okay. Well, different model then. So no, this is a model that is actually used quite frequently. And you see big companies picking this up, like, oh, this works for them, so it will work for us as well. Like there's a big bank in the Netherlands, I'm not going to name them. They have an orange logo with a lion in it. And And they adopt this model blindly, like, yes, this is how it works, and they just hire like 20,000 chapter leads and 20 or 10,000 squad leads, whatever it's called. The thing is, the Spotify model worked for the company called Spotify. Even if it's not here in Russia, you might have heard of it. And it's a company that grew really, really fast, like from 3 people to 3,000 people in 2 years. And they needed a model to support that. This stupid model, actually, well, it's not a stupid model, it's a nice model, but they actually have like 2 managers for every developer or something, or the other way around, I don't remember. The thing is, it worked for them because they were an extremely fast-growing company. If you're a big bank in the Netherlands and you're using this is not you, right? They stopped thinking and just implemented a particular model. And whether that model is actually Scrum or Safe or Spotify, sorry, and or Holacracy or whatever model you might be using, if it isn't you, you shouldn't be doing this. You shouldn't just copy the Spotify model or Safe or Scrum. You should always think for yourself. What works for us? That is what is the most important part of this. So basically, Enterprise Agile, if you cannot even do an Agile project with 5 people, what makes you think you can do Enterprise Agile? Right? Besides, what is the point in that? There is none. So, what I think is, we should move beyond Agile. We should go into what I call the continuous mode. We should stop doing sprints. If you have sprints, usually it works like this. At the start of your sprint, you collect a bunch of work that you think you can do during that sprint. Then you do some stupid estimation technique, maybe t-shirt sizing or planning poker. You could actually quit that, but this is the short version of the talk. Otherwise, I could talk about estimation for about an hour. But so you just stop doing these estimates. They don't work, actually. So, and then you estimate all the work, and then there is sort of this burn down chart, and you never really finish at the end of the sprint, right? There's always some work left. This is from a project in Belgium. This is sprint 1, sprint 2. So see, the gray part at the end of the graph is the work they had remaining. Sprint 3, sprint 4, sprint 5, and sprint 6. And then the project manager came to me and he said, I don't know what to do. He says, like, they built like on average 98 points per sprint, and we have 3 sprints left, and we still need to do 600 points. And I'm like, so? He says, we'll never be able to do that. We'll hire 100 people from India. That works. So the whole project went down the drain, basically. And the thing is, a sprint is just a mini project. This whole idea about we'll estimate it and we'll deliver just that doesn't really work. It didn't work at a larger level. It doesn't also work here. So what I think you should do is actually stop doing these sprints. Right? Just get rid of them. Just have your simple backlog. Pick up the next most important feature all the time. Just without doing the sprints. If you look at the Agile Manifesto, it doesn't really say that you need 2-week periods or 3-week periods or monthly periods. Yeah, that's something different. But anyway, have these sprints or iteration. It doesn't say. The Agile Manifesto basically says to satisfy the customer through early and continuous delivery of valuable software. Continuously deliver, right? It doesn't say every 3 weeks. It says continuously. That's much more often than every 3 weeks in most cases. Can we do that? Yes, we can. Because you know what? The thing is, we are good at automating stuff. We are good at automating our own work because we are developers. We automate everything. Developers are the most lazy bunch of people I've ever met. Right? If you have to do something 3 times, you look at it like, oh, we can automate this. You'll write a script to automate it. You have somebody else write a script to automate it. Whatever. We can automate everything. And you should, by the way. Because automating stuff makes you faster. It makes you able to deliver much more often. This is part of the Jira board that my team uses. I don't like Jira, but we use it anyway, just like most people. And so this is the Jira board of my team. Basically, the only thing we do is we pick items from the left as soon as we have nothing to do, and we move them to the right. They're done, right? And what we could measure, if we wanted, we don't, but we could measure the time it takes from the item to go from left to right. That's the only interesting metric that's actually left. And then you don't have to estimate it because you have hundreds of items. It doesn't really matter whether XL or L or they have 2 points or 4 points or 5 points. Because in the end, if you have enough items, they will average out anyway. That's called the law of large numbers. So you can stop estimating. And automating everything also means that you have to automate your build process. This is the pipeline from one of our microservices at the company I work for. And it runs through all these stages in like 3 minutes. That means it's automatically tested everything, put it into a Docker container, do static code analysis using Sonar. It actually does security checks as well since last week, and it deploys it somewhere. It runs integration test, deploys it to the next environment, runs the whole end-to-end test, and then it goes into the acceptance environment automatically, and it's there. And then the product owner, whoever does that, can click on a button and put it into production. And that is a process of about 5 minutes. Right? So we could deliver software every 5 minutes in every one of our small components. And that is the way that's where we are going. To do this, you also have to automate testing. Are there any testers in the room or QA people? Good, because you need to automate your work as well. We cannot have people that do manual testing, filling in humongous spreadsheets, clicking on buttons, writing down the result, clicking on the next button, writing down the result. You cannot have that in your projects anymore because it's way too slow. So you need to automate. Testers will need to learn how to write code, basically. They do. On my own teams, the testers now know how to write Java. Some of the testers even know how to write TypeScript. And they write their tests in code. They don't test manually anymore. You're just the thing we're now building, and we look at it a bit, and then it goes through the pipeline, and that's all automatic. And that's much, much faster. It's much more continuous. That is what we need to do. And the same goes for infrastructure. If there's operations people having to maintain this particular computer somewhere in the basement and patching it and adding new stuff to it and putting a new hard disk into it, that's gone. Because the hardware is not in the basement anymore. The hardware is sitting somewhere in the cloud. Whether that's a private cloud or a public cloud, we run it. So we're a company from the Netherlands. Half of our software is in Frankfurt, and the other half is in Ireland. Just because we can. We don't have the hardware anymore. That also means that infrastructure, in our case, so we don't pet it anymore, right? We don't take our hardware to the vet and then inject it and keep it alive as long as possible. If it's broken, we'll throw it out, right? Because it's virtual anyway. We'll just push on a button, a script runs, and our whole infrastructure is there again. Infrastructure is way too complicated to do that manually. You have to do databases and upgrade your whatever. I'm not going to talk about NPM anymore. Anyway, so all of this infrastructural software, which basically mostly is software anyway, if it's broken, throw it away, pull in a new one, script runs for 5 minutes, your whole infrastructure is there. Your whole Docker container, your Kubernetes, your console, your Nomad, your MongoDB, everything's back up again, right? In like a minute or two. You never get that when you keep on patching your current hardware. So also infrastructure is going to be code. And it's going to be automated. So we automate everything. And that means we'll end up with something really, really simple. I believe in having approaches to software development that are much more simpler, even simpler than the 16-page Scrum guide. Because the only thing you need to do is automate everything, pick up the next item from the roadmap, start working on it, talk about it with your coworkers, with your friends in the team, build it, ship it, done. Next thing. That's the whole cycle, right? It makes our life really, really simple. And we can do that. Also, you have to stop doing projects, by the way. So, last subject, and I have like 7 minutes for it or something. It's going to be talking about teams a little bit. So teams are usually already smaller when you move into agile. Like the Scrum guide or Scrum predictions say, it's usually 7 plus or minus 2 people. That is very arbitrary, I think. So I think that we should move on beyond that. Because, you know, in teams, good working teams have great communication. Now, communication becomes much harder if there's more and more people in the team. If you have a team of 10 people, there's 45 direct lines to communicate. Possibilities, right? Possibilities to organize all sorts of meetings. I don't like meetings, let's put it mildly. I don't even like stand-up meetings. I've been in stand-up meetings for 20 years already, right? I've seen enough of them, basically. You just talk to each other. And if you have a small team, like a team of 3 people, communication is easy, even with developers. It's usually, project managers always say, oh, you guys, you don't know how to talk to customers. No, it's because you don't let us talk to customers, you idiot. That's because, well, but the thing is, if you do this, and if you want to build software fast, you need to be more autonomous. You need to be able to set your own rules, to set your own guidelines. And we are not really good at that. And I found an interesting picture to explain that. This is, you might think, what is this? It's a herd of sheep. And they were used to running through the gate. So there's a gate in the middle of the picture, going through the gate every day. Now what the farmer did, he removed the fence. So the only thing that's left there is the gate. Still, the sheep are running through the gate. Isn't that stupid? That's us, right? Well, not the farmer, but the sheep. So you need to get rid of these fences, and you need to go around. And that's not easy, because being autonomous isn't always easy. It doesn't mean, like this is at the Zappa's office somewhere in the US, that you have to be weird. Most of the people I work with, they don't want to do this. They just want to write code, basically, right? So it doesn't have to look like your own living room at the office. It's nice. I like having a couch and a table tennis and stuff like that. It helps me, but it doesn't help me write code. Most of the guys on my team these days, they wear noise-canceling headphones because of all these open office, right? So there's a sort of anti-movement in here. Or look at this picture. What do you think this is? This is my girlfriend at a job interview for a very high-level IT position, right? This is not the IKEA. This is a very well-known web shop in the Netherlands, basically. It's overdone, right? So being autonomous and being self-organizing is not that simple. It's actually pretty hard, because it's way out of most people's comfort zone. It is. It's basically like this. It's very hard to explain how to be self-organizing, right? If you try to teach people how to draw an owl, you can say, well, you draw 2 rounds, and then you figure out to do the rest. It doesn't work like that. It needs change, and change is hard. But it's a good thing, right? So you can be the one that starts to change, because there's only one person needed to change stuff, right? If there's the first car coming in Monday morning, parking it the other way, the rest will follow, right? You, having been here, you are the ones who can change the way your companies work. Make life simpler. Stop doing meetings, stuff like that, right? Stop doing projects. Oh, I already told that, right? And the thing is, what we figured out is that less rules makes us happier. Doesn't mean no rules, it means less rules. This is a crossroads in Amsterdam. And what they did is, it was a very busy crossroads. And they, at one point in time, did an experiment. They removed all the markings. They removed the stop signs. They removed the lights. You know what happened? People started to communicate about how to cross the crossroads. So if there's a guy coming up from the left in a BMW, you'll let him pass, because he'll run you over anyway. But if there's somebody with a baby in a carriage, you let them pass first. You look at each other's eyes, you talk to each other, right? People started to communicate. So if there's less rules, communication becomes much more important, right? In traditional teams, we didn't do that. We had different disciplines and different teams, and maybe you still have that. And when Agile came along, what happened is that we created multidisciplinary teams, which is already better. I like it a lot. And now the movement I see is that we are moving into, I call it micro teams, saying that there's a group of people working on a project or a product, and continuously with every item you pick from the backlog, you look at the people around you, say, okay, could you help me with this? And you form sort of a micro team, 2 or 3 people, maybe 4, whatever. Maybe you on your own, work on a particular item. When it's done, you pick the next one up, and you start reforming your team into a different shape. And it happens automatically. It's basically a very natural way of doing things. And I think more and more companies will start moving to do this. Maybe unknown, but they'll do this. And the most important part is, you will have to keep on learning, especially in this field, because we're moving so fast. Everything's evolving so fast, you need to be able to learn. And by the way, stop doing projects. So, to conclude this really, really fast, we have never been in the field that we could do projects the way projects are meant to be in construction and stuff like that. Don't do it. It didn't fit our industry. It has never done that. Think that you are in the complex zone, meaning you have to figure out a way to deal with trouble all the time, to deal with changes, to deal with new ideas. Stop doing all this traditional stuff. Waterfall is long gone. It should have never been there, by the way. You know what? This is, I think, where we are going. Building in very... Oh, I am going too fast. Wrong button. Sorry. We will build products instead of projects in really, really short cycles, even shorter than agile, with very, very small teams who are self-organizing. Don't let other people set your rules. Make your own rules, right? And we build smaller components, but I'm not going to talk about that. And I'll skip this one. Just bear in mind, there's a long story behind that picture, but bear in mind that it is you who does the work. It's you as a developer who's changing the world. Always think for yourself. Don't just copy somebody else's model, right? Even though most of us developers are just butt ugly, this is how it is, right? Thank you for having me. Thank you for indulging me. I hope you have a great conference. I'll see you next time.
Okay, question time. Just raise your hand and the special people are going to approach.
Hello. So far, this was the best speech for the day, so thank you.
I'm not really sure that's a compliment, though, but thank you anyway.
As I see what you taught us, that this theory works if you build features on minimal viable project that are independent, but if features somehow interconnected, the theory of rising complexity start to work, and the time of implementation any new feature start rising also exponentially, like a Moore's law.
It could, yes.
What should we do in that case?
Well, underlying, so there's, in a 35-minute talk, you cannot touch on all the points that you need to do this. If you have an increasing growing product, there's one thing that's really, really important is that you keep your architecture clean. Is because basically what will happen is you don't do that and start adding features. There was actually a slide on that in the deck in the longer version, but if you continuously add features and not spend time on keeping your quality up, that's usually what happens, right? You continuously make the choice between keeping your quality up and adding new features. If you only add the new features, that means that your quality will go down. So you have to spend time on your quality and keep your architecture clean.
Thank you.
You're welcome.
Hello.
Hi.
Thank you very much. Very nice talk. And I am sort of a testing specialist.
Good.
And I have a question for you. Have you already automated your programmers? Do your programmers still writing your code manually?
Yeah.
Oh.
Well,
you must.
Yeah.
That's, of course, it's kidding, but it was pity for me to hear that your tester don't test manually. That's for me almost that you don't test at all. But I wanted to say that programmers and testers, they test, they do their work not manually but brainily, like.
Good remark. Yes, what I mean, we test a lot. We spend a lot of time in testing. And what we do is that the testers actually write the code to do the test, right? Yeah. So we have tests for almost everything. It's very rigorously, but still it goes fast because they do it in code instead of repeatedly doing all this manual stuff.
Probably a good idea to automate regression and routine. Yes?
Yeah, very good idea.
But not testing. Testing is brain.
No, yeah, yes, I agree, yes.
Hello, my name is David, I'm here.
Where's here?
I'm here.
Yeah, that's a
to the left.
to the, oh, right.
So,
It doesn't help if you say, I'm here. So am I.
yeah, so I have a question about the picture of Grace Hopper. There was a phrase here like, do we need this right now, right? And the question is, what can be a good reason to do a completely rewrite of a big system right now?
That's a good question. That we should talk for very much longer about it. Rewriting a big old system is not always worth it. Sometimes it's better to restructure it, but it totally depends on whether that was written in COBOL or in Java or in whatever language, and if the architecture is still okay, if you need to add a lot of new features. So the decision about whether to rewrite a system completely is a very complex question, actually, because there's lots of stuff that you need to take into account. So I don't know the exact answer, but I guess it would be 42.
Hi, thank you for your presentation. It's really great. You know, you are right. In more than 90% projects in Silicon Valley are made on agile. But what about huge projects like creating an operation system or IDE or someone else like DB, Oracle, SQL, and so on?
I would split it in smaller projects. Doing big project as a whole doesn't really work. You should split it in very, very small parts. Again, building an IDE or a database or an operating system, you should start small and add new features time after time again until it's mature enough to put it into the marketplace. But it starts small and it adds the features you need. Because over time, when stuff around it changes, that means you will have to change as well, right? So if you would say, I'm creating a plan for creating this new IDE, it will take me 3 years and then I'll release it, then it's probably already outdated before you even release it. So you should do that in small parts as well. And that's what most people do actually these days.
Are they using agile in Microsoft,
Oh yes,
Google, Facebook?
yes,
Yeah,
a lot. And they have moved beyond agile to do it even faster and sure and more continuous, all of them. Yeah, Visual Studio Code is a good example, or TypeScript is a good example. It's like Visual Studio Code started really, really small, right? With a 0.7 version that you could already use. It didn't have everything, and it grew from there, but you could already use it, right? So that's a very good analogy, yes.
Yeah, thanks a lot.
Thank you.